Hello everybody, welcome back. So in this video, I'm gonna tell you a story, a motivation behind, how to solve several differential equations leading to the first, exam that we have. Okay, the first exam. So the first one, let's jump right into it. So the first differential equation we learn how to solve is the first order differential equation. You have this form, like equation 1 right here. So y is a function of x, and we have y prime plus fx times y equals gx. And we need to find y. What is y? Okay. So how do you solve this? It's really interesting. People can teach you different motivation to solve this. But I say that, in order to solve this, you have a dream, right? You only have a desire. So your desire is you want to turn this thing right here into beta times alpha times y prime. Okay, y is beta and alpha. Beta is a function of x and alpha is a function of x. Okay, so why would you do that? Because if you can do this, you can solve for y, right? So let's say that you can turn this into, let's say you can turn the left side of the differential equation into gx. So you have beta equal alpha y prime gx, right? So you have alpha y prime equal gx over beta. So you have y times alpha equal gx over beta integral of this plus c1. So y will equal to 1 over alpha times integral of gx over beta plus c1 over alpha. All right. Yeah, you can solve this integral. You can integrate it. But how can we find beta and alpha? Well, the only way is you set the yellow equal to the blue and see what can we find from that. Oh, desire. In mathematics, they don't use desire. Imagine you're reading a mathematical paper. You say, I desire to turn this equation into, oh, it's so funny. We have a word for it. We call it Ansatz. It's a German word, okay? One of my professors teach me this word. It's called educated guess. So with that Ansatz in mind, we're gonna set beta equal alpha y prime equal y prime plus gx times y, right? Or fx I think. Equal fx times y. And let's expand this. The goal is the goal. Let me remind you the goal. The goal, we need to find beta and alpha. Okay? In terms of what? In terms of fx. Okay? So that we can do that. So let's for this out. Let's for the left hand side we have beta. Remember chain rule, alpha prime plus y times y prime times alpha equal y prime plus fx times y. So you have y times alpha prime times beta plus y prime times alpha times beta equal y prime plus fx times y, and I call this equation 2. Okay, so if you want equation 2 to be true for on y, so everything relate to y or y prime or whatever of the left hand side and right hand side have to equal. What I mean is this term right here and this term right here have to be equal. And this term right here and 1, because y prime on the right hand side equal to y prime times 1 have to equal 1. Oh shoot, it have to be. God. Forget, even though we use the same color, we confuse the heck out of you guys. Okay, yeah. So it have to equal, right? So what do we have? We have y prime times beta equal fx, and we have alpha times beta equal 1. Okay, I'm gonna say this is 3, this is 4. How are you gonna solve this? Well, you divide both sides. You divide 3 by 4. So you have alpha prime of alpha equal fx. Okay. So what is alpha prime? Alpha prime, it has to be d alpha over dx. Alpha equal fx. Because, you know, again, alpha is a function of x. So when I say taking derivative, I will mean derivative with respect to x. Because if I take derivative relate to other things, it will be 0 because alpha is a function of x only. So I'm gonna, you know, separate both sides. D alpha over alpha equal fx dx. Okay, and then you integrate. Okay, so what you have? Alpha ln alpha equal integral of fx dx plus c1. Oh, guys, in this case, I just want to find one alpha. Okay, I just want to find alpha. I don't want to find a family of alpha. Okay, and I don't want to, you know, find a club, you know, like the green lanterns of alpha, right? Like bunch of the same people wearing the same green. I only want to find one alpha as long as it works for my equation. So it's not gonna be C1. I'm gonna pick the most, you know, I'm gonna say C1 equals 0, so that I can find the easiest and the most efficient alpha. Okay. Okay, I'm gonna say C1 equals 0 because I only want to find alpha. One alpha, not the family of alpha. Okay, not a club of alpha, not a green lanterns of alpha, not an organization alpha. Okay, let's move on. So you have ln alpha equal this. So you have what? Alpha equal e to the integral of fx dx. Okay, this is alpha. And what is beta? Beta, according to equation 4, you will have beta equal 1 over e integral of fx dx. Okay, yeah, so guys, we find alpha and beta in term of fx. Excellent. Let's do one example, okay? Let's do one example. So let's say you want to solve the differential equation. You want to solve y prime plus okay, so let me write a statement down. So the goal is we turn this to beta times alpha y prime, and then we solve for beta times y, and then we use this. It's easier to solve tx. Okay, this is the first step. The second step, or algorithm, the first algorithm, we turn to this, then we solve for this equal gx, and then we find y. Okay, I already highlight all of that up here, so if you want, you can look at it. I guess you can plug in the formula even. Like some other professor will teach you the more efficient way of doing that, but this is not for example. This is not for problem solving. This is just for I want to tell you the motivation behind it. So let's do one example, okay? So y prime plus, let's say 2x times y equal x squared. Okay, how are you gonna solve for y? At first you calculate alpha. Okay, alpha in this case will equal to e to the integral of fx dx, right? So in this case fx is 2x, so it become e to the integral of 2x dx, so to be equal e to x squared. Okay, that's alpha. Cool. Now what's beta? Beta equal to oh, this is actually a bad example. Anyway, actually this is a bad example. Let me actually put up a real example for y'all. Like, this is a bad example because later on you arrive with an integral you cannot solve. I don't want to do that. I don't want to freak you out. I just want to find like a legitimate problem. Okay, legitimate. Let me see. Give me a second. I should be able to find for y'all like a legitimate differential equation. So bear with me. Okay, I found one. Okay, cool. Let's yeah, sorry, I actually deleted. Let's solve this one. Y prime minus 4x times y equal 2x. Okay, let's solve this one. Seems legit. So step 1, So step 1, you find alpha. So alpha in this case is e to the integral fx dx. So if fx this case negative 4x dx, so we become e to the power, what is this? This is negative 4 ln x. Again, no plus c in this case because I just want to find one alpha. Okay, if I plus c, I find a solution, a family of alpha. I just want to find one do. Okay, e to the ln x to the power negative 4. E to the ln x is x, so x to negative 4. Okay, you find alpha. Beta, what's beta equal to? Beta equal to 1 over x, 1 over alpha, which is 1 over x to negative 4, which is x to the power 4. Now, so we say 3. Oh, this is not 3. Obviously, it's not 3. 5. Yeah, 5. Okay, not 5, but the... Oh, yeah, 5 become... alpha, which is this case beta, right? x4 times alpha x to negative 4 times y prime equal 2x. Okay, so how you solve for y? You divide both sides by x to the 4, so x to negative 4 y prime equal x 2x over x to the power 4, which is 2x to the power negative 3. Okay, so what you have, x negative 4 times y prime equal 2x negative 3 to the power of 3. So x negative 4y, integrate both sides, you be called 2 times x to negative 3 plus 1 over negative 3 plus 1. Don't forget your power rule, okay? Plus c1. Now, I'm going to plus c1 because I want to find the family of y, okay? So x to negative 4y equal, I'm going to clean up a bit, so 2 times x to negative 2 over negative 2 plus c1 equal to negative x to the power negative 2 plus c1. I'm going to time x to the power 4 for both sides. 4 times this times x to the power 4. This, not that, the whole thing, not the whole thing, this one. Okay, so y equal to negative x squared plus c1 x4. Okay. And that's, my friend, that's how you solve it. You find alpha, you find beta. And yeah, and then you solve the integral. And yeah, that's your y. And yeah, the next video I'm going to talk a little bit about homogeneous, because Bernoulli, I'm not going to talk about Bernoulli, but there's something very interesting about homogeneous. No, actually, we have some time. So I'm not going to talk about how you solve for the homogeneous solution. The homogeneous solution is like you have this differential equation, right? If f x y equal f x t y t, so what you're gonna do is you set y equal to kx, and then you say, okay, dy over dx equal to dk or dx times x plus k, right? And then you sub it in here, and you sub this in 2. You sub this in 2, okay? You have dk over dx times x plus k equal fx y. Okay. Then also and then for a magical reason, which I'm gonna prove for you right after this, you can turn this fxy into g of k. Okay, you can turn to gk. Okay, so dk over dx times x plus k equal gk. Okay. And k, what is k? K is y over x. Okay, so it's separable. You can solve for k, right? You can solve for k. So dk x dx equal gk minus k. I'm gonna clean it a little bit. So dk over gk minus k equal to x over dx. Okay, and this is how you're gonna solve for, and then you use this. Okay, you solve for k in terms of x. Okay, so let's say k equal to hx. Okay, and k, then later you solve for y, because remember k is y over x, so y over x equal hx, so y equal x times hx. Okay, but let me, that's the way you have to solve it. Let me demonstrate to you, because this is, I think it's kind of interesting. I'm not sure if I do it correctly or not, but I'm gonna show it to you guys. So I'm gonna prove something for you. Okay, let's say you have f x y equal to f of x times k y times k. K is constant. I'm gonna say that there existed gk such f x y equal gk. Okay, so how I'm gonna prove, let's say this is state, this is star. How I'm gonna prove the star statement? I'm gonna go the opposite way. I'm gonna assume that let me do this. Okay, how I'm gonna prove star? I'm gonna say assume, I'm gonna prove by contradiction. Prove by contradiction. Assume that fx of y can never equal to gk. Okay, I'm gonna go ahead and assume that. So if this statement leads to something nonsense, okay, it will conclude that this statement is false, which means that fxy different from gk is false, which means that fxy will be equal to gk. Okay, so let's assume that fxy equal to is always different from gk. Okay, always different from gk. So what you have is you have df over dt equal, oh, not dt, dk equals 0, right? Because you know f is not, apparently it's not a function of k, so you want to take the derivative equals 0. So and what is df? Okay, df, if you remember calculus 3, okay, because since f is a function of x and y, we phi f over phi x times dx plus phi f over phi y times dy. So what's df over dk? Df over dk equal to phi f over phi x times dx over dk plus phi f over phi y times dy over dk. Okay, now we have df over dk equals 0, right? So if that equals 0, okay, I mean Dr. Orman in Thermo 2, he taught me this. I mean, I'm not sure if it's right, but I'm pretty sure that he taught me something new. I remember this. Guys, if you take Thermo 2, remember this statement. It's very, very important. So if df over dk equals 0, this statement, this thing right here, and this thing right here have to be 0. Because phi f over the partial of f with respect to x is not 0. Why? Because f is a function of x. F contains x in it. F contains the x element in it. So that it means that that statement cannot be 0. Same with phi f over phi y. Phi f over y cannot be 0 because f contains the y component in it. So dx and dk and dy over dk have to be 0 at the same time. right? There's no other way. So what do you have? If you solve, you have x equals c1 times k and y equals c2 times k, right? You agree with me? Because, well, it's just basic integration, right? So f of x, y will equal to, I'm going to replace x with c1k times k, c2 times k. And do you agree with me? F of c1k and c2k is a function of k. Do you agree with me? Okay, take some of your time to think about it. Okay, f of c1 times k and c2 times k, c1, c2 are constant or number, is actually a function of k. Yeah, okay, I assume it makes sense to y'all. Okay? Okay, and what is this statement? It's nonsense, right? Why? If you go back to our original assumption, we say that we assume that this, okay, f(x) of y is not j of k. And now we have f(x) of y equal j of k. Impossible. Impossible. No way. No way. So we lead to something nonsense. We led to something contradict. We led to some conflict. So it means that our original statement is wrong. Oh, where's that? Sorry. It's wrong, guys. It's wrong. This statement right here is wrong. Okay? So in conclusion, there will exist a function g of k, such that f(x,y) equal gk. That's all. That's all I want to tell you. Okay? That's the proof for you. I hope you enjoy it. Actually, if your professor asks you rigorously prove, I don't know, like, you guys please check my mistake. I might be wrong somewhere. Yeah, but that's how you prove it. I'm too tired for one example, I'm not gonna lie. But before I end the video, I will tell you something. I'm gonna attach, 3 link. Okay, the first 2 link is about operator. Okay, ODE. Operator, ODE. Like, there's a different ODE stand for original differential equation. And the third statement, I'm gonna attach the Mathematica note of ODE. It's really interesting. So this is another way you can solve original differential equation. It's really interesting. I encourage you to read that. Maybe if I have time in the future, I will make a video about, how you read the paper, and I'm gonna provide some insight about it. The Mathematica note of ODE contain original interesting original differential equation. Like, for example, Riccati. I don't know if it's his name correct. Riccati differential equation and more. So I want you to explore. Okay, there's a lot of interesting out there. There's a lot of interesting thing going on. So please go ahead and take your time to explore. And thank you so much for watching my video. I'm sorry it's kind of long. It's 24 minutes already. I try to keep 20 minutes. But without being said, thank you so much for watching my video. I hope you guys learned something. And I hope you have a good night. And take care.